thanks everybody for jumping on here today. We're super excited to talk with other people that are as interested and enthusiastic about AI as we are. We are the team that's behind a new startup called Vectorize. So I'm Chris Latimer, co-founded this company with Chris B, who I'll let talk here in a little bit. Really what sort of led up to this for me was working with a lot of companies who were doing things with RAG, doing things with Gen AI, and got super excited about the space, got kind of frustrated with the state of solutions that were available to people as they were trying to get their data wrangled for Gen AI use cases. And that ended up leading us to create Vectorize. And it's been a pretty fun, journey so far, as I've got to take a lot of the experience that I've had from places like Google, where I was product manager, launching things like API Gateway, as well as, a lot of my more technical skills that I built up over the years, and got to apply those here. And, super excited that I'm on this journey with my co-founder here, Chris Bartholomew. So Chris, I'll let you kind of jump in and give a little background to the folks.
Sure. Thanks, Chris. I'm the other Chris of Chris and Chris. I'm based in Ottawa. I know that this is the AI Tinkerers, and I'm sorry I missed the meetup on Monday. It's the first one I've missed in person. Was traveling. So yeah, like Chris said, I'm the co-founder of Vectorize. This is actually my second startup that I founded. Back in 2019, I founded a startup called Kesk that was acquired by DataStax, and that's where I met Chris. We were working together in DataStax in the event streaming business. I created, and I've talked to it at the AI Tinkerers in Ottawa about the Langstream project, and behind the scenes, we're using that in our Vectorize product. Still believe in that project. And I've been in Ottawa for a while now. I worked at Solus. Some people may know Solus in Ottawa for 12 years. And if you go way back in time, I'm like most people who are old enough in Ottawa, I worked at Nortel.
Awesome. Thanks, Chris. So as we start off, I always like to just level set because it's interesting sort of where we are with Gen AI right now. We have folks that are really just starting to learn some of the techniques, and we have folks that are probably on this call who are pretty advanced and been doing some more interesting things. Just to give you a little bit more context around my journey here, in my last role at a company called DataStax, I was working on running a SWAT team, and basically DataStax has a vector database, and that vector database was being used by a lot of our customers there to build out Gen AI applications. And so I got to see around 30 or so POCs that customers were running, and almost all of them were using this technique called retrieval augmented generation. And that's sort of a mouthful, but the idea here is really just a very simple way for you to retrieve relevant context from the various places that it lives in your organization, whether that's files, whether that's knowledge systems, whether that's SaaS platforms, and to get it into a format that makes it more easy to find relevant information that an LLM like ChatGPT or Gemini or Llama 2 can use to answer questions or to generate content about topics that it was not trained on. Right, so this is a technique that if you've ever looked at things like fine tuning, where you would specifically give a model information to let it, learn new things. This is kind of a fast track here, where you can get up-to-date information from the sources of knowledge, pass it to your LLM as context, and then build out applications that are purpose-built for whatever the use case is, whether that's a customer-facing chatbot, whether that's a content generator for your marketing team, or whatever the case may be. This pattern of retrieval augmented generation is something that you've probably seen all over the place. And essentially, the way that this works, if we drill down into a little bit more of an architectural view, is that typically you have some type, I'm just going to call it a RAG application. Sometimes you'll see the term LLM application or Gen AI application, but I'm going to call it a RAG application here, where you've got a user that's going to pass in some type of a prompt. And so based on the prompt that the user submits, what you're going to do is you're going to use a what's called an approximate nearest neighbor search, which is just a way to essentially say, what's the semantic meaning of the question or the prompt that the user is asking? And let me find the most similar things semantically in the vector database that we can pull together and then pass that prompt plus the context to the LLM on the step 3 down here. And then the LLM will use a combination of all the things that it's been trained on, along with that additional context that you provide, to now hand back an answer that's going to be more relevant, more accurate, and based on that context that that you supplied. And it turns out that this pattern works really well to be able to extend capabilities of foundational LLM models that were trained on just public data to now be able to do things that are, relying on private data that it didn't have any context on. So on paper, this all seems pretty easy. It all seems like this is like, well, gosh, we could go and build a RAG application in the next like 10 minutes. Like, what's the problem? Well, it turns out it's a little bit harder than it looks. And so if you look at the most common pattern that we saw as we were working through a lot of these POCs, it started off with, we'll figure out what data we want to supply to the LLM. We'll figure out whether that's in files, whether that's in systems, things that are available through an API. Maybe I'll pull in some open source libraries to help me with extraction. And then I'll spend a bunch of time experimenting and comparing different vector databases that are out there. I'll look at things like Pinecone and Weaviate and Chroma, and obviously DataStax. We worked with a lot of folks that were looking at DataStax vector database. And I'll figure out a way to get this all populated. I'll build out my search indexes. And then usually this is where folks would stumble, because it's like, well, I've got my vector data all set up and I'm going to send something to the LLM and I'm going to pull back this context. And all of a sudden it was like, wait a minute, I'm getting back results that are incorrect, or I'm getting back the wrong context, or things that are irrelevant that aren't helping the LLM. And in fact, if you pass the LLM context and it's irrelevant things, things that are just not helpful, it turns out that just leads to kind of a cascading failure on your RAG application, where you just get back really, really poor results, because the LLM is going to try to incorporate the context that you told it was important, even though it wasn't actually that important. And so when we dug into this a bit more and tried to understand, well, where exactly in this flow are things going wrong? It turns out that there are, roughly, I'd say maybe a few more than this, but there are 4 primary places that you'll see problems happening. So the first is with data extraction. And so if you've used things like, if you've ever gone down the rabbit hole of figuring out how PDFs are structured, the first thing that you learn is that they are not structured at all. It reminds me a lot of a thing called PostScript. If anybody's ever had the unfortunate experience of working with PostScript, it's basically the way that printers think about how you're going to print things on paper. PDFs are very similar in that there's no concept of, here's a header over here, or I have a table. In HTML, we could look for a table tag, and a PDF, there's no such luck there. And so extracting data, getting the data extracted in the way that you want, can be tricky. If you want to combine different data sources, maybe you want to pull things that some knowledge is out of files, some knowledge is out of knowledge bases. Maybe you're using things like Confluence Wiki, or SharePoint, or Word docs, or whatever the case may be. Just simply pulling out that relevant context is often fraught with problems. You don't get things in sort of the right sequence that you would read them in. Once you figure that out, and once you've solved that problem, now you have to figure out which parts of that, let's say it's a PDF, for example, which parts of that PDF are the right chunks that I want to pass into the LLM, because I probably don't want to pass in, just an entire document's worth, especially if it's a long document, because anybody who's had a long conversation with ChatGPT has probably experienced times when it's kind of gone off the rails, because it loses track of what's relevant and what's not, and what's important in that context to answer the questions that you're asking. And the same thing can happen if you don't chunk your documents right. And likewise, once you've chunked your documents, the whole the whole key to vector databases is this concept of an embedding. And an embedding is simply a way for you to take text and turn it into a vector representation. And a vector in this context is nothing more than just an array of floating point numbers. To humans, those floating point numbers don't have any real tangible meaning, but behind the scenes and the machine learning model that generates those embeddings, that's kind of what we call a hidden state. It's the numbers mean something to the model, and the model figures out how to match different vectors based on similarity using techniques like cosine similarity, for example, if you remember that from your linear algebra days. That's a place where things go wrong. And so figuring out like what chunking strategy should I use, what embedding model should I use becomes a big challenge. And then likewise, when you get into the state where my LLM application is not working so well, figuring out, well, what's wrong with it? Is it the embedding model? Is it the extraction? Is it like my prompt is wrong? And figuring out like exactly where to pinpoint and where to spend your time improving the application overall can be, a trial and error process, to say the least. And then kind of worst of all, once you actually get everything working, it's where you want, it's like you're happy with the results. Well, that data that you use to populate your vector database is probably not static, especially if it's a knowledge base of some sort. It's going to evolve over time. And as it does, you're going to see this drift that will happen between your vector indexes that you've built out and that knowledge base. So figuring out like now, how am I going to keep these things in sync and make sure that I have relevant responses and relevant generated content over time becomes something that you have to think about on an ongoing basis. And so, to kind of dig into this a little bit more, I mentioned embedding models were one of the things that could go wrong. So Chris and I spent, the better part of a day, at least the better part of an afternoon and an evening, right after the OpenAI V3 models came out about a month ago now. And so what we wanted to understand is just how big of a difference can these embedding models make, because we'll see that there are leaderboards out there. One of the most popular ones you maybe are familiar with is called the MTEB leaderboard by Hugging Face, where it ranks different embedding models based on a series of benchmarks that it runs. And one of the things that we have observed is that the results that you'll see on the leaderboard are often different than the results that you'll see based on your data. And so finding the embedding model that works best for your data is kind of tricky. And so we ran an experiment here with the previous generation of embedding models from OpenAI, the Ada V2, with their new text V3 large and V3 small embedding models. And we used a corpus that was actually, we had been playing around with, which is actually a bunch of Dungeons and Dragons manuals. And so we categorized all of the types of questions that you might want to ask about how Dungeons and Dragons works. And then based on the questions that we had in each one of those categories, we ran a combination of the embedding model to create search indexes. And then we used a framework called Ragus, which has a context relevancy score. And so we would run through the questions, we would see what information we would get back, and we would embed that to the vector database. And then we would basically look and see where did we get better or worse results with the new models versus the old models. And overall, kind of what we saw here is that the new models performed a little bit better, but not always better than the previous ones. And what was kind of really most interesting is even we used the smallest of the small 256 dimension vector when we were comparing the small model to the previous generation model. Even that actually performed pretty well. So we're seeing sort of some interesting results. And as we did this, it became clear to us that we could help people, not spend afternoons or days figuring out what embedding models were the best. But one of the things we wanted to do with Vectorize is just help you really quickly get to that data-driven view of which embedding model is going to work best for you. And we'll see that a little bit later once we get into the demo. But before we jump in there, I want to kind of hand it over to Chris to talk about larger context windows and some of the things that are happening there.
Sure. Thanks, Chris. So on Feb 15, this is sort of just 2 weeks ago, Google launched a new model. Finally, they came up with a model that might actually challenge OpenAI's GPT-4, Gemini 1.5. And the big selling point on Gemini 1.5 is the size of the context window. The context window is basically how many tokens, and a token is about a word, the model can either input or output. It depends on the limits. There's limits on inputs and outputs, but how many tokens you can send to the model and it can process. Until Gemini 1.5, we were used to models that were limited in the 10, like, started when they first came out, you'd have like a 4K limit on tokens. Then we got bigger, like Claude came out with 100K, and now GPT-4 is at 128K. And Claude 2.1 moved up to 200K. But Gemini, out of the box, claims Gemini 1.5 claims 1.5 million tokens, 1 million tokens, sorry, and it will scale up. In the paper that accompanied the model, they said they would scale up to 10 million, and they'd done some testing. So just there's a diagram here. You can see how much more context the LLM can process. So this led to a bunch of hot takes, on Twitter, LinkedIn, social media, that Reddit. RAG is dead. We don't need RAG anymore. And I think that's not a correct call, but I can see the argument, right? The argument is that, well, one of the reasons why you do RAG, but just one of them, one of the reasons why we did RAG, especially back in the early days, was, GPT-4 had a 4K context window. So you had to be really picky about what kind of information, because RAG, you're doing retrieval augmented generation. So you're retrieving documents from your vector database, and you're basically stuffing those into the prompt that you send to the LLM and say, given this information, come up with a response, generate a response. So RAG was a solution to that we had limited context window, and now we have seemingly unlimited context window, or like practically unlimited context window. So we don't need RAG anymore. That was kind of the argument that was being thrown out there. I don't think that's quite true. Can you show the next slide, Chris, please?
Sure.
So, RAG is dead. No, long live RAG. I think that RAG is far from dead. So let's first look at whether it can actually, context window, we can give it all those tokens, but can it actually use those? And it came out in the summer. There's a paper from Stanford, introduced the concept when longer context windows were starting to roll out from some of the providers. There was a paper with this idea that, lost in the middle. So the paper demonstrated that, the information at the beginning of the context window was always used, actually, and the information data at the end of the context window was well used, but the stuff in the middle of the context window, the LLMs didn't really use that very well. So that was the lost in the middle concept. And so that was kind of like, context windows are great, and it makes things a little bit easier because you don't have to worry about, being very, very careful about how big your context window is. But, we don't really get a lot of value out of that. When Google came out with their Gemini model, they wanted to sort of prove that the whole context window could be used. And so one of the things that they did is they picked up on this needle in the haystack test. This originally came out from, it was interesting, just somebody on Twitter, Greg Camrant, sort of did this experiment. He took one of the longer context window models at the time, and he said, well, I'm going to fill that context window up with random statements, random facts. And then I'm going to put it at different places in the context window. And then I'm going to ask the LLM, can it retrieve that fact from the context window? This is the needle in the haystack test, right? And the chart at the top is original findings for that. And you can see in the green is like, it could find the needle in the haystack, but it got really bad at finding the needle in the haystack as the context window got longer, and depending on sort of where you put it in the context window. Front of the context window, doesn't matter how big the window was, it was good. You got into the later parts of the context window, hard time finding that fact, trying to find the needle in the haystack. And so that was another reason why it's like, yeah, these context windows are great, but we still are better off, curating the best content and putting it in the context window up near the front. even if it has a large reach, a large size. So Google came out and in the Gemini paper said, "Oh, well, we ace the needle in the haystack test," and it's true. They published the data. They can find the needle in the haystack, across most of the context window, like in 99% retrieval of the needle in the haystack, and that's a great achievement. The question is like, is needle in the haystack really a realistic test? It's not, in my opinion. This is not what you're actually doing. It's not when you're building RAG applications, you're building chatbots, you're building any kind of tool on this. You're not doing like Where's Waldo, right? You're actually want to use all of the context, not one random fact in there. So I don't think it's all that realistic. And so it's great that they've solved that problem. Not sure that it's actually going to translate to real world solutions. And in fact, in the Google paper, they admitted this. They said, the needle in the haystack test is the simplest possible setup. And they did another test where they would do multiple needles in the haystack. And that's the second graph. This is, in my mind, figure 10. The figure, I remember when this came out and I started reading the paper, I immediately sent it to Chris. I said, figure 10 is the reason why the long context window is not going to actually kill RAG. You can see from this scatter diagram, and they've, interestingly, everyone wants to knock GPT-4 off the mantle. So this is comparing GPT-4 to Gemini 1.5, and how good a job it did at recalling multiple needles in the haystack at different context lengths. And red is GPT-4, and GPT-4's context window is 128K, so that's why it's only the sort of leftmost part of the scatter diagram. And you can see it's not that great. It's like getting around 50% recall, and it gets like worse if you look sort of the trend line down. Gemini 1.5 does a better job. You're going to kind of maybe slightly downward sloping line you would draw through that. But you look at where it actually is in the recall, it's around 60%. So it's only able to even find, and this is not even that sophisticated a test, it's just a few more needles to find in the haystack. It's missing 40% of the data that you're sending to it. So it's maybe able to find one needle, but it's still emitting a lot of the information. By Google's own results suggest that it's not able to use much of that context window. The other thing to note is that there was a paper that came out just last week, or maybe it was this week, I don't know, it's all a blur to me, that you might want to check out. And it's not talking about these super long context windows, but it's more exploration into longer contexts and how well LLMs can use them. And I link it in here, and I can share it with you if you're interested. It's called Same Task, More Tokens, exploration of long context windows. That also, if you look at the conclusions from that, is that, as the context gets longer, you see degradation in the ability of the LLM to use the context window. So that's kind of the first thing. It's like, yeah, we have a lot of context, and it's certainly a great achievement, the size, because it's order of magnitude bigger than anything else. But you may be putting all this into the prompt. The LLM is not really going to make great use of it. Next slide, please. So the other thing you have to keep in mind for these long context windows is exactly what the trade-offs are. I mean, nothing comes for free, right? LLMs, to start with, require a lot of CPU and a lot of memory just to run them, which is why NVIDIA's share price is where it is right now, right? And so, if you're going to give an LLM this much data, and by the way, I have a friend who works at AMD. He's telling me, like, if you're putting that much memory, if you're stuffing that much into a memory access for LLM, it's not optimized for accessing all that much data, just by the way it's structured. He said it's going to be slow at accessing the data, and that's true. LLMs are not optimized for processing this much data. And so your early returns on Gemini 1.5 to do 360 context, 600K context window, 30 seconds to 1 minute. So you're waiting a long time. Like, that feels like, if it's an interactive application, that's like an eternity. That's a bounce. I think it's broken. I'm going to go leave kind of response. And even if you don't have an interactive application, some kind of background task. I mean, if you have to wait 1 minute to process one LLM generation, your throughput isn't so good, since there's an inverse relationship between latency and throughput, right? You can only go so fast. So this becomes a very slow process of generation. And then the other thing to keep in mind is how much is the actual cost of it. You know, we don't know the pricing yet of Gemini 1.5. Google hasn't released it. And in a lot of the tests, a lot of the reasoning tests in the leaderboard, it is pretty equivalent. It's pretty close to GPT-4 Turbo. If Google came out, and they probably won't, it'll probably be less than that. But if they came out with GPT-4 Turbo pricing for Gemini 1.5, 1 million tokens would cost $10. $10 for one question to your chatbot. So that's kind of the worst case scenario. If OpenAI was doing this, this is what it would cost. If we use it, what sort of the existing Gemini pricing is, it's quite a bit less than that. But it's still coming out, and the pricing on Gemini, in OpenAI, it's priced by token. In Gemini, in Google Gemini, it's priced by character. If we assume like 4 characters per token on average, it works out to about 50 cents for 1 million tokens. Still a lot of money, actually, because you're looking at 50 cents per question on your chatbot. That adds up pretty fast. That's certainly not something you want to leave, let anyone in the world use your chatbot. You know, end up racking up hundreds of dollars in a day, people just asking random questions. And that's just, you know, imagine a situation where someone's asked like, you know, 15 questions in a short amount of time. Like this has cost you $10, something like that, right? So that's a trade-off. Latency and cost. Right now, these problems are not solved. It's going to cost you a lot of money to run long contexts, and the latency is going to be really bad. Next slide. The other thing is, if you think about this from a sort of a engineering perspective, is like, you know, 1 million tokens is kind of a brute force solution. Is like, I don't want to think about finding the best information to give to put in the context. I'm just going to give it all I got, right? And you know, that can work, right? But it is brute force. So what happens is, like, imagine a scenario where you've built this. Say you have this working your RAG application, and now your RAG application, as Chris was mentioning, is like giving, you know, poor responses, or it's hallucinating. Okay, well, now what are we going to do about it? There's not much we can do with the brute force solution. We can't. There's no knobs for us to tune. All we do is like basically dump all the data into it and hope that we get a good answer. And so I think what happens is you know, you can give it more data, you can give it less data, you can do, but I think what happens over time, you end up building it's like, well, maybe the only logical thing to do is to give it better data. And so you end up building a traditional RAG application anyway, where you, instead of sending it 1 million tokens, you're going to send it the best 10,000 tokens. And then you're just doing a traditional RAG application anyway. The other thing to keep in mind is, like, you know, if you've built any kind of scaled kind of system, you know, getting 1 million tokens into the LLM, the engineering problem is not trivial, because, you know, even if the LLM was down to 100 milliseconds to process that 1 million context window, that would be great. If it takes you 2 minutes to retrieve 1 million tokens worth of data and pass it into the LLM, the overall process is still very slow. And so you need to think about that. It's like, how do I get 1 million tokens into my LLM per call? Not a trivial problem. You know, do you pre-extract the data? You know, if it's sitting in PDFs, you know, you probably pre-extract it, because you don't want to extract it every time from the PDFs, the text. So then now you got to put it into a database, and now we have to recall from a database. And you know what? You're still doing RAG, right? We're doing RAG no matter what. We're augmenting the generation with retrieved data. So, you know, RAG is not dead. RAG is a pattern that I don't think will go away, even if the context windows even get bigger, the costs come down, the latency comes down. You're going to do RAG. Maybe you don't need a sophisticated vector search, and maybe you know, there's some simplification you can make in the pipeline, but I think RAG is here to stay for sure. So next slide. So, keeping that in mind, that RAG is sort of, you know, here to stay. What is Vectorize? And this is the product that Chris and I are building right now. The idea behind Vectorize is it's a universal way to extract data from unstructured sources, and that can be like files in different storage systems like S3 or Azure Blob Storage or Google Drive, but also like other systems of record. You know, Zendesk for customer support tickets, Jira for you know, internal tickets, Confluence for wiki. any kind of source, Salesforce, all of that kind of stuff, is you're going to consume data and unstructured data for the most part from all of these systems and sources. And then you're going to be able to take that data and build a production ready pipeline that consumes it, loads it into your vector database with the proper embeddings. And then as that data changes, it's not, as Chris mentioned, we deal with the drift. You don't want it to drift. You want to have the latest data. So we monitor the state of the data, and it's changing. If it's changing, we update the indexes so that when the retrieval part of the augmented generation happens, there's always the latest and greatest information to inject into the prompt. And the last thing that we do is just like the insight that we have is that it's hard for people to figure out, what is the best chunking and embedding chunking strategies, embedding models, and that. So we've built a experimentation framework inside Vectorize for you to experiment with different options, and also, to get good quantitative and qualitative insight into whether your RAG application is working well. And I think, one thing to focus on is we're taking a data first approach, right? We're not like doing LLM ops. We're not Langsmith. Langsmith is a great tool. It's great for understanding what the LLM is doing. But, at the end of the day, if you don't have the right data, your application is not going to work. And that's what we're trying to help people figure out is, do I have the right data? Do I have the right approaches to getting the data into the databases, into the vector database? Is there another slide? Oh, yeah. So this is, I don't know how much time we have.
Maybe we should just show.
Yeah, we just show it instead of talking about it. Why don't you just flip into the demo of what Vectorize is.
Yeah, and that way hopefully we'll have a little bit of time for some questions here at the end too. So let me just share a different window here on Google Meet. So yeah, in the spirit of AI Tinkerers, I mean, this is something that Chris and I are in the process of building out right now. Super excited to share it with you. It is a little bit early, so say a little prayer to the demo gods that they'll be kind to us here today. But this is Vectorize. This is the product that we've been working on. And anybody who's gone through this process of RAG, especially RAG with a vector database, has experienced the realization that I need to get my vector database populated some way, shape, or form. And that's actually where we started off, as we said, well, that unstructured data could live anywhere in your organization. It could live places like, files. It could live in S3 buckets. It could live on the web where we need to crawl web pages. It could live in places like Salesforce and Zendesk and knowledge bases. So we wanted to make it easy to connect into those systems. And then we don't want to be a vector database. You've already picked your vector database. And so we said, we'll work with any of the vector databases that are out there, Pinecone, Weaviate, DataStax, and so on. And the idea here is that you configure the source connector and your vector database. And then once you've done that, we have this concept of a vector pipeline. And a vector pipeline is basically just a way for you to connect your source systems. In this case, I've got an S3 bucket with a vector database. In this case, I've got DataStax Astra vector database. And then we can specify some configuration here around exactly what I want to include in my vector pipeline and the vector search index that will get created. In this case, I'm using an S3 bucket. So we see things like, do I want Word docs and markdown files and whatever I find in this S3 bucket. If this were something like Atlassian and Confluence, I'd see things here like, what wiki spaces do I want to ingest, or what pages within a space do I want to ingest? And then likewise, this is the source side. On the destination side, we can select from the different embedding models and chunking strategies that we want to use. And then we can come in and just give this, some type of a name here. And once we create this will essentially do two things. It's going to do an initial load of the data from your source system and do all the parsing, all the chunking, all the embedding, push that into the vector database. But then it also will create a watcher, and it'll look for changes that are happening on that source system. So in S3, if I delete a file, we'll delete the vectors that were part of that file. If I update a file, we'll figure out what changed in there. We'll update the vectors that were generated from that file. And likewise, if you add a file, we'll add new vectors for the content that was in there. But as I mentioned earlier in the talk, one of the things that we saw people run into is I'd get to the end and I have this pipeline generated, and all of a sudden my results were not great. I would see things that were not I wasn't retrieving the relevant results that I expected. And that led us to create this idea of an experiment. And the idea here is to help you get really, really quickly to not just a populated vector database, but a database that's populated in the most ideal way that's optimized for your data to answer the type of questions or to generate the type of content that you're most interested in. And so what we do is we provide you with a out-of-the-box database engine that you can use, and we let you take a sample of your data. And by sample, this can be any type of like PDF or Markdown or text that you just upload here. If you were, working with wiki content, you would just go and export that as PDF, for example. And then what we'll do is we'll test out different embedding and chunking strategies for you. And then we'll see how relevant those results are based on the types of questions that your data is good at answering. Now, how do we figure out what questions your data is good at answering? Well, first thing we do with this experiment is we extract out the text. So in this case, it's PDF. So we'll look at all of the different chunks of data, the tables that come out of there, headings, and so forth. And as we pull that data out, we will generate a set of questions for based on the content that we got. So we'll look at a chunk, we'll ask an LLM behind the scenes, hey, I've got this text, what sorts of questions would this be good at answering? Now, in this case, I'm using some reports from a company called IDC. It's a market research company. And these reports will tell us, well, this data would be good at answering questions like, what is the significance of having an analytics control plane for Global 2000 enterprises according to this prediction? And we'll run those chunks through all the different embedding models that we have as part of this experiment. And then we sort of bring those two things together and we do the scoring step. And the scoring step just goes through all the questions and it says, how well, if I retrieve from this search index that's using Mistral with this recursive text splitter, how relevant using a relevancy algorithm were those chunks? Do they provide good relevant context to the LLM? And we do that for each one of these different combinations and each of the questions in each of the categories. And then we don't have it quite yet here because we are in the tinkerer mode still. But what you'll see here coming up in the next few days to a week is that we'll essentially have a winner. And we'll say, based on your data, based on the types of questions that your data is good at answering, and oh, by the way, if these aren't the types of questions that you're interested in, it doesn't matter what else we do. You should rethink your data strategy, make sure you have the right context. But assuming this is good, and assuming that you now see which of the models works best for you, you can feel fairly confident that you could take this and create a pipeline from it. And then based on that pipeline, you're going to have not just a fully populated pipeline, but it's going to be populated in such a way that it's optimized for your use case for the types of questions that you want. You know that it's going to be up to date. And instead of you going through and doing a whole lot of different experiments of trying things out and using gut feel, you get data to back this up. And then sort of where we're headed next is this idea of a RAG sandbox where we combine this as well. So here's what we think is the winner based on our data, but don't take our word for it. Come into the RAG sandbox, play around with it, see if you agree and if you are happy with the results that it provides. If you are, promote this into a pipeline, and now off you go. You don't have to worry about all the things that could go wrong from a data engineering standpoint. You don't have to worry about learning all the APIs to connect to things like Confluence or how to extract data from PDFs and figure out chunking and embeddings and so forth. It's all just going to be taken care of for you. You're going to have the right search index. It's always going to be up to date. And now you can go focus on the parts of your RAG application that are most interesting to you anyway, which is the part that is customer facing, is going to solve the business challenges that you're trying to solve. And so that's in a nutshell, really where we're headed with Vectorize, sort of where we are and our tinkering journey as we're building out this product. And really excited to get a chance to share this with all of you today. And hi, thanks for inviting us to be part of this event. And I think with that, we're happy to open it up for some Q&A in the last 5 minutes.
Okay, so I got one question. And the whole reason why I got you guys on here is because I have this one question. So what is the cream of the crop, state of the art, best practice for RAG? What's like the 80-20 for RAG? Like if tomorrow I want to make 5 changes, what should those changes be?
If you want to, well, I mean, I think, so there are a number of actually, this is a great question. Hi, I'm going to answer it probably not the way that you're hoping I'm going to answer it, which is like straightforward. I've got the magic secrets for you, like the 5 keys to like building RAG. One of the challenges that I think we have with RAG, and one of the things that we're trying to solve for folks, is that there's so much happening and so many emerging things. So, for like a while, there was a thing called Flare, and Flare was like, oh, this is like the secret to doing really good RAG. And then there was like re-ranking, which has still got some legs behind it, and people are doing re-ranking. And then lately, there's been a thing called CRAG, or corrective retrieval augmented generation. And as practitioners, it is really, really hard for anybody to keep up with the overwhelming number of new papers that are coming out on arXiv. So part of what we're trying to do is we're trying to take that cognitive burden from folks and to say that we will implement a lot of these things for you and give you an experimentation framework where you can see, like, maybe CRAG works great in some use cases, but does that mean it'll work great for you, for your use case? Not necessarily. And so part of what we're trying to do is to help you figure out, like, of the state of the art things that are coming out, and which is changing like every single day, which of those things are actually going to be meaningful for you and to give you improved results. I'd say things you want to look at, just to at least give you like some concrete part of answer to your question. I'd say looking at things like at re-ranking of results that come back are going to give you are going to be important in terms of making sure you have the best context. And obviously,
Query, query
ahead.
rewriting. Yeah, I think query rewriting, like at the beginning and end of RAG, I think doing query rewriting, which means take the query or whatever your prompt is and basically ask an LLM to rewrite it so that it better reflects the kind of thing that you want to retrieve. So you get a better match. That's the front end, and at the back end, like Chris says, a re-ranking. Now you get the results back. Like, if you have a large corpus of information, there's probably duplicate information in there. And similarity search is simple. It says, how similar are these things? If there's 5 identical pieces of text and they all are highly similar to the question, then you're going to get 5 duplicate pieces of text, and that doesn't really help things. So re-ranking can help sort that out and make sure that you're not repeating yourself in what you're telling the LLM or what you're giving to the LLM. Sorry, Chris.
No, I think that was good.
Yeah.
Awesome. You sound like my business advisor. It's like, well, depends, right?
It depends. Yeah, everything depends.
We tried to give you at least something concrete on there. I know that's like the most unsatisfactory answer for a technologist ever. Looks like there's a question in chat from Ajay. Great presentation. Love to get together. I have to jump off. Oh, okay. Not a question. Just thanks, Ajay. Love to follow up with you after this. We'll reach out.
Yeah. So the floor is open for questions. Anybody wants to jump on, feel free to unmute yourself and speak away.
One other note I'll add to your question, Hi, is, and this is why we have the generation of the questions in the documents. One thing I found when I was experimenting a lot with RAG systems is that, it's the data. The data is the most important thing to get the response back, right? And if you don't actually have the right answers in the data set, then there's no hope, right? So, I think that's important to look at. What data are you actually putting in the vector database that you're trying to retrieve from? And that's kind of the idea behind generating questions. Is like, it's pretty obvious. Like, those are good questions that your data can answer because we generated them from the data. But if those aren't the right kind of questions you expect your users to be asking, then you have a problem, right, with your input data.
I do have a quick question. So I know, like, the examples you guys show were mostly like text corpus, PDFs, like regular corporate documents. But what about like code bases? Like, what about like code text? Well, how would that be different in terms of RAG?
So I think there's a lot of similarity. There are both LLMs as well as embedding models that are purpose built for code, right? So you wouldn't. In fact, this is sort of an emerging trend we see in general. It's probably the first example we saw where things would split off between text and code, and now we're even seeing sort of more branching off of embedding models into things that are specialized for like finance docs or for legal docs or for so forth. So I think you want to make sure that you're using sort of the right models that have been built to deal with those type of corpuses. And if you don't, you're gonna have a bad time. You're not gonna get very good results back. Yeah.
I'd also say that there's different chunking, like because code, there's obvious semantic breaks in code that's triggered by the syntax of the code. There are specific chunking strategies that you can use that are tailored to the code base. And then you should use those because that will get you better chunks rather than sort of random chunks. And so like popular frameworks, and we haven't added this yet in, but that's on our roadmap, is to be able to add in chunking strategies that are tuned to Python or tuned to JavaScript or whatever your language you're using.
Makes sense. Yeah. There's a question in the chat. I'm just going to read it out. So will the user interaction with Vectorize.io be checking, unchecking different data sources and evaluating the results of automatic ranking returned?
So this is like the retrieval endpoint, right? Right now, the answer is no. We don't. We're not in your runtime path of your RAG application. You go right to your vector database. However, Chris and I are talking about that. If you have a use case around this, I'd actually love to talk to you about your thoughts on this, Jalen, to get some user feedback, because so it's a topic that we're actively discussing as part of our roadmap and when and how we sort of add some features around this. So would love to dive a little bit deeper into that with you. But in the short term, no, you'll go right to your vector database just like you would today.
Great, thank you. Yeah, the question was because I didn't get enough time to read all the things that you showed in the what came back as a ranking and the results. So
Okay.
yeah, that was a good question for that. Yeah, okay, we can check back later for questions.
All right, sounds good. And
Sounds great.
I think we're a little over high, so probably a good time for us to wrap up.
Yeah. Thank you guys for hopping on. Thank you for showing us Vectorize. You guys been working on this for like the past couple of months, right? So it's very early stage.
Yep. So we do have a wait list where the wait list is open. If you go to vectorize.io, that is our website. Feel free to add yourself to the wait list as soon as it is available. We'll be happy to give the Ottawa Tinkerers, AI Tinkerers, early access to it. And the other thing we would really appreciate, we are on Twitter, we are on LinkedIn. If you guys would give us a follow, that would be great. We always want to keep up to date with the latest that's happening, and we'll try to publish out useful stuff that you guys would enjoy. So I would appreciate that a lot.
Yeah. Where can people find you on Twitter? What's your handle?
Yeah, so let me just pull it up really quick because we're wrapping up. So we're at Twitter, we're Vectorize.io, all one word, and same thing on LinkedIn. You can look for Vectorize, and you'll see our little black box with a V with brackets around it. That's just our logo, and that's how you know it's us.
Sweet. Awesome. Thank you.
Well, thanks everyone. Really,
Thanks everyone.
the talk today. Have a great rest of your day.